All right, so this is going to be part 2 of a particle question involving acceleration and the antiderivative. So my first video, I already found the velocity time function, and that velocity time function is circled in blue here. So 2t minus 4t squared plus 12. The next question involves just a little bit more work, and it says, or asks, find the distance traveled for the first 5 seconds. So from 0 seconds to 5 seconds. So the first thing you want to do is, since we want to find the distance traveled, we need to find the position time function. So remember this relationship right here. If I take the derivative of a position time function, I get the velocity function. However, we are given the velocity time function and we want to go the other direction. So once again, we have to take the antiderivative of the given, or actually we found it, the antiderivative of the velocity time function. So I'm going to start off by actually writing the function here. So this is number 1, find the antiderivative of the velocity time function. So v of t is equal to 2t minus 4t squared plus 12. And I need to take the antiderivative to find the velocity time function. So I'll state it as, or not velocity time, position time function. So it's going to be 2t squared divided by the new exponent 2 minus 4t cubed divided by the new exponent 3 plus 12t plus s naught, which is our initial position, and it acts as our constant when you take the integral or antiderivative. Okay, so if I clean this up a little bit, I have s of t is equal to 2t squared divided by 2 gives you t squared minus 4/3 t cubed. Can't do much with that fraction there. Plus 12t plus your s naught, which is that initial position with respect to some origin. Okay, so we are traveling on a line here. Okay, so the next thing you want to do, since we are finding the distance traveled, we need to figure out what are the turning points. What are the turning points for this particle? Meaning, when does it change direction? Because we can't assume it's going to be traveling in a straight line the whole time. It might actually come back forwards and backwards, right? So to find out where it changes direction, we need to actually find the critical values. So find the critical values for the velocity time function. So remember, velocity tells you all about direction. So let's work with that velocity time function. We have it up here. We found it in part A of our question. So I'm just going to state it here. V of t is equal to 2t minus 4t squared plus 12. So let's find out what these critical values are. Remember, critical values happen when v of t is equal to 0 or when v of t is not undefined. So we are looking at this situation right here. So let's make this equal to 0. So 0 is equal to 2t minus 4t squared. We do have a quadratic here. I'm going to actually list it in a descending order by degree. So negative 4t squared plus 2t plus 12. To find the critical values, you obviously need to do some PSA factoring here. First thing I would do is actually take out a negative 2. So if I take out a negative 2, I'll negative 2 in front, and I have 2t squared minus t minus 6. So watch the sides here when you take out a negative. Once you PSA factor this quadratic here, and I'm not going to show it because you guys should be quite comfortable with that by now, you're going to get 2t plus 3 t minus 2. So here are my critical values here. I have a critical value at t is equal to negative 3/2 and t is equal to 2. Watch the domain here though. We are looking at time between 0 and 5 seconds. So one of these is actually considered an extraneous solution, and this is the extraneous one. So that does not work. So we're looking at this critical value. This is where it has a turning point. So it's going to change direction here. Okay, so to find the distance traveled here, this is going to be step 3. I need to figure out where this particle is at certain times. So I'm going to find where the particle is at 0 seconds. That's going to give me my initial position. But watch what happens here. Let's go back to the actual position function. It's up here. Okay, so I'm going to write it out. Actually, I don't have to, because I just want to state, if I'm going to put 0 into this function for t, I am going to get 0 here, 0 here, 0 here, and I'm going to be left with s naught. Which makes sense because at 0 seconds, that's where your initial position is. So you're wondering, how do we find that value? This actually becomes unnecessary in the end, and I'll show you why in just a minute here. Let's find the position with respect to the origin at 2 seconds, so when it turns, when it goes backwards. And to do that, we're going to sub it into the position time function. So let's go back to the position time function up here. We have t squared. So I'm going to put in 2 now, 2 squared minus 4/3 t2 squared, or 2 cubed, sorry, plus 12 times 2 plus s naught. Okay, so watch what happens here. If I evaluate all of this, and if I write it as a decimal here, I'm going to get 17.3 plus s naught. So what this means is it's 17.3 units forwards, okay? So it's plus s naught, so it's going to be to the right or forward, okay? Let's figure out the distance at 5 seconds. So that's going to be our endpoint right here. If I put in 5, I'm going to have 5 squared minus 4/3, 5 cubed, plus 12 times 5, plus s naught. Okay, and if I calculate this correctly here, you're going to get negative 81.7 plus s naught. So since it's negative, this means it's going to be, I should say left. Actually, left is a better word here, and then up here I'll put right. So it's going to be left 81.7 units from the initial position, so s naught. Okay, so if I actually draw a diagram here, I'll show you what's happening here. So here's s naught. Here's my initial position. After 2 seconds, I'm going to be 17.3 units to the right. So if I draw this, that's 17.3 units. Then after 5 seconds, which is my endpoint, I'm going to be negative 81.7 units to the left of the origin. Sorry. So to the left means I'm going to be over here somewhere. And of course, it's going to be a bigger line, but of course I don't have that room here. So negative 81.7 is that distance right there. Okay, and let's discuss this distance right here. That distance actually is the same as 17.3. This is equal to down here. Okay, so let's actually calculate this distance now. So the distance after 5 seconds, is total distance is equal to 17.3. So that accounts for this distance here. Then we add another 17.3. We end up back at the origin, plus 81.7. Okay, and then once we add up all these values here, we're going to get a distance of 116.3 meters. So that is pretty much it for that question. It is quite lengthy, so lots of practice, guys. There's one in your assignment just like it, so take your time and obviously, work through all the steps. And that's it.